Remember yesterday we showed you the first images released by a powerful new telescope in Chile, marking the start of a decade of filming the southern night sky.
Yeah, the Vera Rubin Observatory houses the world's most powerful digital camera, and it's released even more images of the universe. In just 10 hours, the telescope detected more than 2,000 new asteroids and 7 space objects that are close to Earth.
Scientists say if a ninth planet exists in our solar system, this telescope is going to find it. Amanda Banerjee, Professor of Astrophysics, I can't even say it, Astrophysics at the University of Southampton, joined us now. Morning.
Morning.
Good morning.
Hiya.
These pictures are incredible.
They are, aren't they?
And there was a moment yesterday, wasn't there, where all of the pictures came through, and there was a real sense of celebration, because this is, in the science world, this is breaking news.
It is. It's absolutely revolutionary, and we are so excited as an astrophysics community, because this has been decades in the making. This is an absolutely groundbreaking new facility. It has so many technological revolutions. So it is a big telescope, but it's incredibly agile, incredibly fast. It can move really fast across the sky. And as you said, it's got the most powerful digital camera ever built. So we can take stunning images, but do that really fast, and do that many, many times over the next 10 years to build up this ultra-high definition time-lapse movie of the cosmos, which is going to change our view of the universe.
So what can it show us that we haven't been able to see so far?
So the possibilities really are endless with this telescope. So what you can appreciate in these images that have been released is the incredible detail. So we have a very powerful camera. It's 3,200 megapixels. And a lot of what you're seeing are sort of zoom-in images, because to be able to display the full detail of these images in all of its glory would take the equivalent.
Here we are. Now, here we are. This is what we want to see. So what on Earth, or out of Earth, is this?
So what we're seeing here are lots and lots of beautiful stars and galaxies scattered across the cosmos. You can see the incredible diversity in their shapes, sizes, colours. So over the next 10 years, Rubin will map these in incredible detail, where they are, what they're like, how they're distributed across the universe. And what you're seeing, I just want to emphasise, is a tiny, tiny glimpse of what this observatory will do. So in the initial zoom-in that you showed, it was 2% of a single Rubin image. Wow. And then as you zoom out, you see kind of a full Rubin image. And we're going to do that 1,000 times over the sky. We're going to do that hundreds of times over the next 10 years. And it is this time-lapse movie that we're building up that is so revolutionary for astrophysics. There's all sorts of things that we're going to find that we haven't even thought of. And I think that's why we're all so excited.
Yeah, and that was, my question around, this will let us discover new things, because we know there's a lot out there already.
Yes.
But this gives us more detail and actually things that we just don't know about yet.
Absolutely.
What potentially might we find, and how important is it that we know it's there?
So Rubin is built on sort of 4 science pillars. So you said we've already found 2,000 new asteroids. Over the course of the 10-year experiment that we're going to do, we're going to discover millions of new asteroids never seen before. We're also learning about dark matter and dark energy, which are these mysterious components of our universe that we know very little about, but they make up 95% of everything in our universe, the stuff in our universe. Everything that we see around us, that's just 5% of the stuff that's out there in the universe. But by mapping these galaxies, looking at their colours, the way they're scattered in the cosmos, we can start to build up this picture of the fabric of the universe, the dark matter, dark energy. And that's just a few of the things. So what you can see here is these very detailed images of galaxies, of nebulae, which are clouds of gas and dust. And using those images, we're going to answer really fundamental questions about the growth of our own galaxy, how that fits into everything else that's out there in the cosmos. It is so exciting.
It's literally life, the universe and everything, isn't
it?
It is,
all absolutely, absolutely.
And possibly a 9th planet.
Possibly a 9th planet, yes. So there has been a lot of speculation by astronomers about the existence of a 9th planet. If it is there, and some astronomers do believe that it's there, then there's an 80 to 90% chance that Rubin will find it. The reason no other telescope has been able to do this is because no other telescope can see things as faint and as far away as Rubin can. And we don't quite know where this ninth planet is, so you also need to look at very large portions of the sky. And Rubin combines all of those capabilities. So if it's out there, we should be able to see it.
So exciting.
Absolutely.
Come back and tell us how it's going.
I will do.
Yeah. So nice to see you. Thank you for being with us this morning.
Thank you very much.
Thank you.